Hello, this is the third part of the chapter 2.2, and today we will talk about the algorithm for finding the inverse matrix. In the previous parts of the series, we discussed how to find the inverse of the two-dimensional matrix, and there is a really nice determinant formula here which can help us. In the modern two-dimensional, there things are a little bit complicated. There is not precise formula, but there is a neat theorem 7 over here which tell us how we can approach the finding the inverse matrix. And the theorem here tells us that if there is an invertible for our matrix n by n matrix A, it should be a row equivalent to the identity matrix. So if we find this row equivalent form, we can easily extract this inverse matrix. And it probably sounds complicated, so I'll guide you through step by step through the algorithm for finding the inverse. And I also demonstrate all the steps using this three-dimensional matrix A. So we will go ahead and find it inverse. Okay, and we're starting the step 1 of our algorithm is always writing an augmented matrix. So we take our matrix A and we augmented it with an identity matrix of the same size as our matrix A. So basically, we take our matrix A and put an identity right next to it and combine it as a new matrix. Okay, so that was easy, isn't it? Let's just go ahead and make a next step. That involved a little bit more operation. We need to apply row operations to reduce our augmented form from identity matrix being on the right to identity matrix being on the left. So we're kind of using the, like shifting it into the row echelon, reduced row echelon form. Okay, let's see how that works. So we start with our matrix and we will start reducing it. And of course, we'll always start with the first column, and this bottom element 4, it should be 0. So we apply the row operation. So now we already have a pivot columns in the first column. Now we need a pivot position in the second one. So instead of -3, we should have a 0 here. Okay, now first two column, perfect pivot positions. Let's look at the third one. So we want to have 1 here, instead we have 2. So we need to divide by 2 to have a proper matrix. Okay, so now we have a diagonals equal 1. This is what we want for identity matrix. But we also want to have identity matrix have a zeros above ones and below. So in here we have 2 and 3. So again, we use the row operations to get the zeros. And at the end, look what's happened here. Instead of having the identity matrix on the right, we basically shifted it to the left. And the good news for us here is whatever's on the right of our identity matrix is actually our inverse matrix A minus 1. So the step 3 now is just extracted the right part as an identity matrix. Okay, so we can write down our A minus 1, and you're pretty much done here. However, I strongly recommend you to go to the step 4 and always, always, always check your final answer. We know that the product of matrix with this invertible should be equal an identity matrix. So either you're doing a homeworks or exam or quiz, always check your result by multiplying your original matrix to an inversible one. So we start with our matrix A multiplied by inverse. And again, I'm not gonna do this like algebra here because you probably will fall asleep. It's a lot of numbers here. I leave it to you to calculate, and I strongly recommend you conduct this all operations and confirm that indeed we have an identity matrix. Okay, and that's all about algorithm for finding the invertible matrix. So now I would like you to go to the questions assigned for the next quiz and start practicing.